Slope of polar curves. What is the slope of the line tangent to the polar curve r equals 1 plus 2 sine of theta at theta equals 0? Okay. Okay, so there is a formula for finding the slope of a polar curve. It's rare enough that it's almost not worth memorizing, and the derivation, it's a little bit of a pain. We're going to go through it. I'll let you decide if you want to memorize the formula or not. It's completely your call. It might be a better use of your time practicing other type problems and just being able to derive this, but you'll see. Let's go through this. So the slope of a line is dy dx. Well, you can also do dy d theta over dx d theta, which when you divide fractions, you get a multiplied by the reciprocal. So you have dy d theta multiplied by d theta dx. And this is almost more mnemonic than fact, but it works. It works well as a mnemonic. And so what we want to find then is dy d theta dx d theta. So if we have our triangle here, we have a theta, we have an r, we have a y, and we have an x. And y would equal r sine theta. X equals r cosine theta. So if we do dy d theta, like so, dy d theta equals, now this is going to be the product rule. The product rule is uv prime equals uv prime plus u prime v. So let's say u equals r, v equals sine theta. So for y then, we have r times the derivative of sine theta, which is cosine theta, plus derivative of r with respect to theta, which would be dr d theta. I'll do a d theta. Nope, we're good there. So I was thinking about doing the chain rule for the cosine theta. Theta is theta, so taking the derivative of theta is 1, so that chain rule is not required. Well, you can say it is required, but then the derivative of theta with respect to theta is 1, so multiplying by 1 is not a big deal. Okay, back up again. Dr d theta, which is derivative of r with respect to theta, times v, which would be sine theta. Dx d theta, do this one a little bit more formally. We'll say that u equals r, u prime equals dr d theta, v equals cosine theta, v prime equals negative sine theta. So then u v prime would be r sine of theta negative plus u prime v, which would be dr d theta times cosine theta. Okay, putting this all together, we have dy dx equals this divided by that, which I'm going to flip them around a little bit just so that the negative sign for the dx d theta is on the right. Sine theta plus r cosine theta all over dr d theta cosine theta minus r sine theta. And this is the formula for the slope of a line using polar coordinates. And you can see this derivation, not that hard, but it's going to take you a couple minutes. And when you only have a couple minutes to do a problem, you don't want to spend all your time deriving things. But with that said, this is a complex enough formula that it's difficult to memorize. You can memorize it, but it'll take a reasonable will of effort. And the cost-benefit analysis of doing that might not be worth it. So the goal of the AP test is not to get a perfect score. You can get a 5 with like 60% of the points. But even then, you don't even want a 5 per se, because you just want the highest score to get whatever credit for the university that you're going to is. So the only reason you shoot for a 5 is because it's less likely you'll get a 3 if you're aiming for a 5 than if you're aiming for a 4. So, cost-benefit analysis, your call. I wouldn't memorize it. And if I came across a problem like this, I would probably skip it until I finished the other problems. Maybe. It depended on how much time I had. If I had extra time, then I'd just go for it. If I was tight on time, I might skip it and then come back if I have time. Okay, so now we need to find dr d theta. Come up here. dr theta equals, so that goes away, and we're left with 2 cosine of theta. Okay. I'm just going to copy and paste this guy. Well, copy move up here. There we go. Now, sorry. There we go. Move it over here. I'll take our dr d theta. Move it down. There we go. Perfect. Well, adequate. Ooh, I don't like orange. Okay, blue. So, writing this all out, and you don't really have to write all this out because we're already given that cosine of theta equals 0, or no, theta equals 0, cosine of theta equals 1. You could plug in 0 at this point and simplify everything, but for clarity, I would kind of like to keep this, write this out as much as I can. Plus r equals 1 plus 2 sine theta. I think it's 1 plus 2 sine theta. 1 plus 2 sine theta, okay. 1 plus 2 sine of theta, cosine theta, all over 2 cosine theta, cosine of theta, plus minus, ooh, convenient, 1 plus 2 sine theta, sine theta. Okay, so this is our slope for this parametric equation. Not parametric, polar. Parametric is when you have like a dummy variable. T, so to speak. Okay, so now we need to plug in 0. So we have 2 cosine of 0 is 1. So we'll do 1 sine of 0 is 0 minus 1 plus 0 times 1 all over 2, that's cosine, times 1 minus 1 times 0. Get my canceling out. Goes to 0, goes to 0. We're left with negative 1 over 2. No, plus. That's a plus. Plus 1 over 2. 1/2. So we're left with 1/2. Okay? Yep, and that's the answer. Right there. So, as you can see, slightly involved. Is it worth the effort to memorize the formula or derive it every time? Your call. I prefer the derive method, and what I'm banking on is this is not that common of a question, and when it does come up, you just kind of punt it, or if you have extra time, you give it the extra time that it's going to demand. And that's how you generally approach finding the slope of polar curves.